Hello, everyone. Thank you for joining this webinar. So my name is Arnaud Stoffer. I'm part of the HyperWorks product management. And today's meeting objective will be to review the section property tools and so-called Hyperbeam in HyperWorks and how we enhance it and move forward toward its deprecation. So just as an high-level update quickly for this version 2022.2. The main focus of today's will be the capability enhancements that we've been adding with the integration of a BIM section and all of the engine with a Sketcher as a sketch entity and Sketch as a client. We'll review some of the usability enhancements made using the browser itself to allow quickly create and edit everything from browser, as well as new context which has been created towards the panel removal of the old Hyperbeam. And regarding the tool, which was already there in a previous version, there are several announcements and a bug fix that came with this version. Some improved performance for the section property. And one important point is the new elastic section, which was introduced in 2022.0. Didn't come with a 3D persistent visualization. And even in .1, that 3D visualization was only live in session. But now we save everything to the binary and can restore it. Okay, so quickly, in a nutshell, browser, I go quickly through this one. But just was to mention that from a browser standpoint, for years, HyperWorks was able to generate from a browser BIM section of a type standard and generic. While in the last release, in 2022.1, a new BIM section configuration was added called Elastic, and it was possible to create it from the browser. But the legacy section, like a shell and solid section, was not available through the browser and only limited to panel by a creation from a section cut or data in model. So we just unlock this capability. So everything could be done from browser itself. And along with this, we provided many more functionality directly available from the browser, like absorb a sketch, auto welding, editing in Sketch. But we'll go through this aspect now. But before I dive into the functionality itself, it was to review the infrastructure updates that we made. So first, we have introduced a link between a sketch entity, so the inspired sketch that can be read inside HyperWorks. That same sketch could be used to define BIM section. So it was already possible in last version, again, 2022.1, to generate an elastic section out of the sketch. But that one was limited only to a closed loop sketch. And shell and solid was not referenced by a sketch, which is now possible. But before I do demo that, I need to state one point. So the main key point is that now a BIM section is defined by an engineering geometric definition, which is a sketch. And Sketch knows nothing about the BIM section itself. So it's a geometric definition. But along with that, we have a tabular data. So sorry, during the meeting, I might call it a part manager, and I want just to stress that it has nothing to do with the part entity from HyperMesh itself. Yet, once we consider a BIM made of several domains and we inflate that BIM, each and every domain has to become a part. So that's why it's called part, and the legacy shells BIM section was using part anyway. But the key point is that sketch, for instance, that we see on screen is made of 4 different domains. One hat, one plate, which are all of type shell, and 2 wells here. And each and every domain is a collection of unique ID lines. So once defined, it will remain the same whenever the sketch will be updated. And we can assign a size. And again, we'll see that depending on the type of a domain, size will stand for thicknesses or for mesh size. Once we define a link between a BIM section and a sketch, that a BIM section has to listen to that sketch. So there is 3 ways to update a BIM section, either by entering a sketch edit mode that we will see, then we can delete parts, add some part, or change the sketch itself. And the moment we enter that sketch edit mode, then a BIM section will not react automatically. So it will help us to change drastically a sketch without calling the engine at each and every change. If we change a variable because we have a parameterized sketch, we can change some variable either through the variable manager or parameter entity. Then that one will lead to a live update till and until we are not inside the sketch edit mode, which again will freeze the signal. And the third part of the update could be changing the tabular data by changing a mesh size or thickness, which itself will lead to a live update. Okay, that being said, what does it mean for shell section? So the shell configuration section is still using the scene wall theory behind the scene, which means that each and every domain is a collection of line plus a thickness. And then once we define a sketch, we will actually realize that sketch will be realized onto the legacy point, which by now we still allow in this version to to review a beam section inside Hyperbeam. But the moment a sketch is attached to a beam section, then that edit mode is disabled because that's the main driver, and we can't do any modification on the realization itself. But if we remove a sketch and reset it, then that realization will be kept. It will just be an orphan beam section like the legacy one. And then editing will be available in Hyperbeam. And just quickly, we'll review that there were a function called auto weld. That one for now just play on the realized entity, not on the sketch itself. So to say, whenever you will change that sketch parameter and so on, it will turn onto a new realization, and that weld has to be called again. But the best actually is to introduce the weld inside the sketch itself. So you can have the constraint manager and every facility of the sketch, and then they will be persistent. So when it comes with a solid realization, a solid has always been a 2D meshed section, so it needs to have some closed loop. So definitely, if we have a sketch where we do have at least one closed loop, so HyperMesh is able to create a surface, that will be a valid sketch for a solid. It's allowed to have some scratch, some lines outside of this, they will simply be ignored in this case. But worth to mention that the moment you have more than one domain, because by design, solid was a single domain, a single region. If you have more than one domain on your sketch, then if those closed loop are nested closed loop, then they will be understood as a whole. So Sketcher itself, I mean a sketch client here, doesn't show anything like a whole. So here we can see that we have many circles and each of them are domain. But we can understand them whenever we assign to a solid, we will understand them as a whole automatically. And a -1 on material is just a trick here. It stays at -1 and it's not editable. So it's just to let the user know that each and every circular will be holes here. So basically now, if I edit that one onto Hyperbeam, we can see the realized mesh for it. And as mentioned before, there was a size. So in this case, size is not thickness, but will be the mesh size used. Using 0 is a recommended one, is an auto mesh. If we want to change really and provide a numerical value, then that one will be the actual mesh size that will be used during the realization. So we can make the mesh coarser or finer. We just pay attention to the size of your section according to the mesh size used, because it might hamper the performance with a too fine a mesh. And dealing with the last configurations that we've been supporting, the elastic section, that one was introduced with a tool that we will see afterward called section property in order to update beams by the result of a cut with a model. Would it be a solid, shells, and so on? That one internally consider everything as a solid, which means that whenever we were cutting surfaces or 2D mesh, we use a thickness assigned to it and inflate it, and it becomes a solid domain. So the main improvement now is that we have a concept of hybrid definition. You can have one part which is defined as a line, and it becomes automatically a shell domain, and we will assign a thickness to that shell domain. And if you have some closed loop, then it will be understood automatically as solid domain. then that size on the tabular data will be hybrid in this case. For solid domain, size will stand for the mesh size, while for a shell domain, size will stand for thicknesses. And again, I state that now we save the 3D visualization of this configuration with or without a sketch being assigned. So demonstration here, I have one beam section which is pointing of type shell pointing to a sketch. And since this one is used to a property, I just reset it to become an elastic section. I assign the same sketch and he recognized everything as a shell, but since the thickness was not correct, just by updating the tabular data, we can now have the part with a small gap, yet since it's elastic section, it calculates the torsion constant by contact. Now by entering the edit mode in Sketch, we can actually select one line and do an offset, which will turn a linear domain onto a solid here, basically, with this offset 5. And since it's an hybrid definition, I have to make sure that the original line will be removed. So now we change it to a construction line, so you won't have any duplicate domain at this location. So as you see, till we exit, nothing happened. And the moment we exit, then the beam section will react. So we recalculate the number of parts, and here we see that we have a solid part and a shell part. And again, now we can change the shell part thickness or the solid mesh size. Okay, so if we do have some legacy model, whenever you have some legacy model with existing beam section, we did provide an API to absorb those one. So we can absorb legacy beam section and it will actually create a sketch out of this legacy beam section. So for instance, in this example here, by absorbing it, it turns onto these polylines. We basically, for shell, because shell was the only one having the concept of a part, we inherit the part with name and the actual thicknesses of the original part. And this absorption is valid for both shell and solid. So here, using this example, I have an existing model which was made using the skeleton, and I have a collection of beam sections. So if I isolate this one, you can see the shape, and let's just review that one in the legacy tool, so Hyperbeam. So if I actually load this model inside Hyperbeam, and we try to edit that one, first we see that that's a collection of vertices and a straight segment, which was made of 3 different shell parts and let's say 4 welds with a thickness assigned. Okay. So it's technically possible to select all beam section and absorb all. Here we just select that one of interest, and we can absorb a sketch. Now, it has automatically created a sketch and infer the part from the legacy beam section. So now we can see the same parts name and same thicknesses. And from there, we can directly change the thickness of one of part, which the moment we proceed will trigger the engine and recalculate all of the section property. For instance, here, change to 1.8. Okay. But once we get a sketch, it's possible now to do edit in Sketcher. And the main point is that since it was defined by point, we actually create a sketch which is a polyline with control points. So sometimes it may be a bit smoother than it was in the original section. So we might have by now to update slightly that sketch. But in any case, by changing that sketch, the moment we exit, and the 3D visualization did react to that one, and the engine reacted to. And if we reopen Hyperbeam, we can see that realization has been regenerated to the same placeholder. So nothing is broken from a workflow perspective. Mapping to solver property and so on will still remain the same. But now we give a chance to review in Sketcher and parameterize some section. So why we did that? Actual point is that you would have noticed HyperMesh is able to read a STMod file. So it was already the case. But the main integration now is that if you read an STMod file where you do have some parameters, we do first of all support the parameters. which are the sketch-based parameters and even the non-sketch-based parameter. And if you actually provide a path, and if you have Inspire installed on your machine, then you can provide that path. And the moment you update a parameter, it might be live if you turn this option on, or it might be an asynchronous if you go to CAD update only. It will actually update the geometry in batch and will replace the representation of your geometry in HyperWorks by the new updated one. So the main interest here is to use a sketch and variable as the main glue between the 3D CAD and our 1D modeling, because the same sketch entity here will drive both the geometry representation as well as the engine. So, from a context point of view, we've been releasing already some tools called section property, which aims to do beam update from intersection with the model. That one has been extended, so it was able to support elastic section and shell section. VAPS is a separate cases only for OptiStruct. We did extend that one to support, first of all, the solid section, and I will go through the new option where now, along with the section creation, we can generate a sketch and assign that sketch. So we already fixed a few of the issues that was already reported on consolidation. Yet, till now, I forget to mention that whatever I shown before is available for all configuration and for all solver profile. For that particular release, till .2, those contexts themselves are exposed only for OptiStruct and Mathron due to timing constraint for validation. But the next plan will be for next release to expose for each and every solver profile that actually support beam sections. So kind of announcement which was made, as mentioned, it's a small illustration of now the new solid section being added. And we used to have a direct update. Now, as we will see later on, we have one pull down, which is called update beam versus section cut or planar. And if I turn off here, in this case, the create sketch, just for sake of demonstration, using the 1D to be updated and that solid as a source. Here we are doing one cut per 1D in order to update the 1D at each and every location. So it has generated a bunch of solid beam section as an orphan section. Yet those ones are valid for simulation, and they behave like the legacy solid section. If we simply undo this and turn on an option which is valid not only for solid, but for all the type we support, we can, along with this beam section, generate a sketch. And a good point is that now you have the same beam section, but it has a reference to a sketch with this tabular data, and we can edit each and every beam section on the sketch itself. And yeah, it's just a dummy update, but just to illustrate that by changing that sketch and escaping that sketch, you will have the engines that will be recalculated and 3D visualization of all beam referring to that section, which has been updated. Similarly, we do have a shell section. So I just want to demonstrate a similar behavior, except that here we have a complete workflow. In this case, we are able to actually update beam section from that section cut. That model is actually a model which has several parts, and let me expand this flange. If we see those parts, we have two different thicknesses, 10 and 15. 15 was for the web and 10 for the rest. And I just change each and every thicknesses here, just to random value. We can clearly see that the flange was increased during the 3D visualization. And since the engine has been recalculated, the offset is not valid anymore because shear center was moved. But now we reposition the shear center, and using the inflate tool, that was the main point, we can actually regenerate a new representation of that same shell mesh. So now in this new component here, I have a new mesh which represents the correct shape of the updated sections. and have the correct thickness, which is assigned to it. So that's another way to reduce your model, change and optimize your model, and then regenerate the original representation of that model for more detailed analysis. Okay, so that was the update on the existing tool. And in order to move forward for the panel removal. So in HyperWorks, for years, we have been adding some functionality in a Hyperbeam page. So under 1D Hyperbeam, there were a way to generate standard section, generic section, shell, or solid section. So standard and generic section has been removed already in a previous release because they have a provision to be created in a browser. But shell and solid was the remaining tools. And shell and solid can be created from a planar entity, so planar lines, so planar 1D for shell, planar 2D for solids, or from a section cut on a model. And it has several options to update the beams. Sorry, to update the beam section, like changing, repositioning the origin, do some auto weld, or delete some unused. So I just mark with a color code here what is already ready to be removed because it's fully covered from other functionality or other context, like the delete unused directly have the context that delete each and every unused entity in the database. Others are covered by whatever I shown from the browser. And if those panels are still there in .2, it's because actually the limitation to time constraint was we validated all of the new context only for OptiStruct and Nastran. But for .3 release, we will have the QA validation for all profiles, so then that will end up, and we will be able to deprecate those panels. So using the same concept as the section property tool, we have been introducing new tools called section cut and planar. But here we do select some sources, and you will do a single cut. And worth to mention that now, using this manipulator, we can define the user-defined y-axis. And your beam section y-axis will match with this user-defined y-axis. So if I proceed, for instance, with this specific orientation, and since we turn on the create sketch at the same time, we can review in sketch that generated section. You can see that that section is tilted because it matches actually the user axis that we did select. Now, it has a collection of parts because by intersecting shells with different thicknesses, we generate part per thicknesses in this case. So in a similar manner, we could actually generate from planar entity, and we do filter based on the valid entity for a given config. So shell is not valid to select a shell element for planar, but it's valid to select some 1D element on some lines. And here we just create a beam section out of the inferred plane, so with no selected option. And it's how it looks like by the auto-oriented plane. But if user is not satisfied with this plane, you can turn off this inferred plane and select your plane. The point that we pick will be the origin of that system. Then we can change the normal of that. And if it's not exactly normal to the source, it will be projected on this plane. And here again, defining the y-axis will leads to the section y-axis. So by defining a point at any location, here we just continue with a solid from shell. It gives provision to get the moment of inertia at that particular local system. Usually the moment of inertia, everything is calculated against the centroid, and that's what the property are using. But if you want to know at a special point, then beam section already outputs the value at this origin of the system. So yeah, it was just to complete the demonstration that, yeah, solid. And yeah, what was to mention, sorry, was to mention that in this case, we were using a beam section orientation, sorry, a beam section origin, which is slightly different from the sketch point origin. So that's the third data name which has been added. No matter what the sketch that we use with a different origin, we can change where the beam section origin is in the section. So from an API standpoint, we have been adding everything that was shown here could be totally automated. So we've been introducing a new API or enhance one API, which was already there, the update 1D element, which now supports Sketch and can generate solid section. And all of the Hyperbeam API, everything is consolidated under those two API, which is beam section create from section cut or beam section create from entities, where they have several options, including the ability to generate a sketch along with a beam section. And that third API is the one which could run from the browser directly, that will actually absorb a bunch of shell or solid beam section and generate a sketch and assign them to those beam sections. Worth to mention that if a beam section already has a sketch, that one will have no effect, so it will not overwrite that sketch. So with that, that summed up the slide. Thank you.